So today we have section 2.2, Inductive and Deductive Reasoning. We're going to be filling out pages 14 and 15 in our interactive notebook. Starting with page 14, you should see the definition for conjecture up at the top. So that's our very first vocabulary word for this section. And a conjecture is an unproven statement. And that's going to be based on observations. Okay, your next vocabulary word after conjecture is going to be inductive reasoning. So you're going to use inductive reasoning when you find a pattern in specific cases, and then you're going to write a conjecture for that general case. So the very first example is just taking a look at patterns. So you are just going to either write or draw the next two numbers or figures in each pattern. So you'll see in the first example that you have a full circle and it's cut in half. Then you have a full circle that's cut into thirds. And then a full circle that's cut into fourths. So if you have 1/2, 1/3, 1/4, the next pattern, the next term in this pattern should be fifths. So you want to take a circle and then cut it into fifths. So 1/2, 1/3, 1/4, 1/5. The next term should be 6. So you want to take a circle and cut it into 6 pieces. So that's more of a geometric pattern. Parts B and C are numerical patterns. So you have to take a look at what's happening in order to get the next two terms in the pattern. So you have 5, 4, 2, -1. So as you can see, the numbers are decreasing. So I'm going to see if there's any pattern by subtracting. So to get from 5 to 4, you would subtract 1. To get from 4 to 2, you would subtract 2. To get from 2 to -1, you would subtract 3. So if you subtract 1, subtract 2, subtract 3, the next number you should be subtracting is 4. And -1 minus 4 is -5. So if you subtract 1, then 2, then 3, then 4, the next number that you're going to subtract is 5. And -5 minus 5 is -10. So the next two terms in this pattern were -5, -10. Part C, it looks like the values are increasing in this pattern. So you can look and see if there's anything that you're adding in between each one. So if you take a look, see if you can add, you find a pattern when you add values. So it looks like the first one you would add 15/100ths. The second one you would add 17/100ths. And then the third one you would add 19/100ths. So it looks like we're doing some odd numbers here. If you take away those decimals, you would see 15, 17, 19. So this is 15 hundredths, 17 hundredths, 19 hundredths. The next number that you would add is 21 hundredths. And then 1 plus 21 hundredths is 1.21. So then if you have 15, 17, 19, 21, the next odd number is 23. So you would add 23 hundredths. And that would give you 1.44. So basically what you did is you used inductive reasoning. You might not have known that that's what it's called until now, but using inductive reasoning helps you then find terms in patterns. So that's one of your vocab words, is inductive reasoning. The other vocab we're going to practice in example 2. So if you open up your notes, we're going to practice now making and testing conjectures. So it says, numbers such as 3, 11, 15, and 29 are odd numbers. Make and test a conjecture about the product of any two odd numbers. So basically, you're just going to be multiplying the numbers that you're given to see if you can find a pattern. So you would multiply 3 by 11, 3 by 15, 3 by 29. Then you can multiply 11 by 15, 11 by 29. And you can multiply 15 by 29 and see if you can get any pattern. So multiply 3 and 11, 3 and 15, 3 and 29. Then you can multiply 11 and 15. Multiply 11 and 29. And then you can multiply 15 by 29. And you want to take a look at what patterns you observe. So if you multiply an odd number by an odd number, what did you notice about the product of an odd number and an odd number? So looking in this column, it looks like the product of an odd number and an odd number is going to be another odd number. So that's the conjecture that you would write. You would then write in a complete sentence, the product of any two odd numbers is an odd number. So that's how you would test a conjecture, and then make a conjecture as just a complete sentence based on the pattern that you observed. So to show that a conjecture is true, you must show that it is true for all cases. To show that a conjecture is false, all you need to do is find one counter example. And that's what we're going to do in example 3. We're going to find a counterexample to show that this conjecture is false. So a student made the following conjecture about squaring numbers. Find a counterexample to disprove the student's conjecture. So the student's conjecture was that the value of x squared is always greater than the value of x. So what you want to do is just kind of test this conjecture. So what if you used x is 3? Is 3 squared greater than 3? And in this case it is, because 3 squared is 9 and 9 is greater than 3. So we showed that it's true. So you want to just keep testing this conjecture until you find something that's false. And that would be your counter example. So it works for 3. You could test to see if it would work for like a -3. So is -3 squared greater than -3? So -3 squared is 9, and 9 is greater than -3. So again, we just showed that it's true. It's true for a positive value of 3 and a negative value of 3. So we have positive, we have negatives. I wonder if this works for fractions. So what if we used a third? Is 1/3 squared greater than 1/3? So I know that 1/3 squared is 1/9, but 1/9 is not greater than a third. So here's a counter example. So if x is 1/3, this conjecture is false. So testing a conjecture, you just want to see if it works for some positive values, some negative values. You could try fractions and decimals. You could try 0. But all you need is one counterexample to show that it's false, and that is it.